Hey, what's going on, guys? In this video we are going to take a look at multiple inputs and registers in Logisim. So first we are going to see all the necessary gates with multiple inputs and then the register as well. So let's look at the AND gate first. So here we have AND gate and I'm going to put 5 inputs to this. So I just copy paste this input 4 more time. Okay, to analyze the AND gate's behavior, I put the output as an LED light over here, and we are going to see when it will turn on and when it will turn off. Okay, for an AND gate to be turned on, all of the input has to be 1. Even if it's 1 0, then the LED lights won't turn on. So here if I put 1 here, it doesn't turn on. If I put another one here, it doesn't turn on. If I put another one, it doesn't turn on. It only turns on when all of them are 1. Okay, that is AND gate. And if I look at OR gate, similarly I put 5 input for that, so I copy all this input and then paste it over here, grab it over here, and then connect the wires. Okay. Now let's add an LED light at the output. And for a OR gate, it's opposite. It at least has to be one has to be 1, and others anywhere can be 0. So it has to be 1 here. You can have more than 1 as well, so it turns on anyway. And the 1 can be anywhere as well, and it turns on. So if you have 1 here turns on, 1 here turns on, 1 here turns on. So it at least has to be 1 1 in order to turn on. And you can have more than 1 as well. And if you look at the XOR gate, that is slightly different than that. That is if you put output for this one, in the input you cannot have more than 1. So I copied all the input and then connect the wires. Make some space. Okay, here we need to add only 1 1 to turn on. So here it can be 1 1 anywhere and it turns on, and if you have more than 1 1, it turns off. So it has to be just 1 1, and if it's more than 1, it turns off. That 1 can be anywhere. So this can be 1, or this can be 1, or this can be 1. Like that, it can be anywhere, but it has to be just 1 1 to be turned on, otherwise it turns off. And if you look at this NOT gate is basically the opposite of whatever it is. So here if you attach a NOT gate, it is going to turn off. So whenever it turns on, if you attach a NOT gate, it turns off that time. Whenever it turns off, it turns on. It does the opposite of whatever happens. NAND gate is actually attaching a NOT gate at the end of the AND gate, and then NOR gate is actually attaching a NOT at the OR gate, and then XNOR gate is basically attaching a NOT at the XOR gate. So these are actually give the opposite output of whatever the original one gives. Okay, if you look at the odd parity, so odd parity, even the name says it all. What does it do is, when you have odd number of 1, it turns on. So 0 considered as an even. If I attach a LED light, when none of them are on, it turns off, because 0 considered as an even. And when it's 1 1, it turns on. When it's 2 1, 2 is the even number, so this is an odd parity. So it only turns on when it's only odd numbers of 1s. So 2 1s are even numbers, so it turns off. 3 1 are odd numbers, so it turns on. 4 numbers are even, turns off, and then 5 odd number turns on. And then even parity, as the name suggests, it has to be even numbers of ones. Okay. And if I connect an LED light here, 0 considered as an even, that's why it turns on whenever even we don't have any input of 1, because 0 considered as an even number, so it turns on. If it's 1, it turns off, because 1 is odd, 1 is odd number, 2 1 is even number, so it turns on. 3 number 1 is odd number, turns off. 4 even, turns on. 5 odd, turns off. And these are the gates. Actually, these are all the gates we looked at. And then the next one is we are gonna look at the register as well. Register you see in the memory, it's right here. So register is basically when you input, it stores the input, and whenever only you can release using a button, then it releases to the output. So to visualize that, we put an input for this, and here the register is an 8-bit, so the input also has to be an 8-bit. So I have to change the bits here to 8. Otherwise you see the orange wire, because the with the incompatible, so it has to be same bits right here. And then output also has to be same. So for the output you can use the LED matrix, or you can use the general output as well, it doesn't matter. So if you want to illustrate like an LED light, then LED matrix is for the 8 bits you can use. So here again this column has to be 8, row has to be 1, and instead of column I make it into rows. Okay, I have to make the columns to be 8 and rows to be 1. Columns to be 8 and rows to be 1. In that way we get a shape like this. Then we connect this one to here. Okay, now we add a button for this. Button you can find it in the input and output. So you connect a button over here, and then with the button you can control the memory. So for example, if I input 1 and 1 here, now it's stored in the register. Now until you release with the button, it is stored right here. Now you can release by clicking the button. Now it's released right here. So you change anything and then click the button, you release right here. So like that, you know, this register is a storage device, so you can store something and then release using a button. Okay, that's it for this video. See you guys on my next video.